Okay, so now we're going to look at estimating the population proportion P. Now, the point estimate that we're going to use for the population proportion P is the sample proportion P hat. And P hat, the sampling distribution, is actually centered around P because P hat is an unbiased estimator of P. So it's centered around P and is normally distributed. So here's the formula for the margin of error. Notice it involves a z-score. So we're going to actually find the area from the normal distribution here, the standard normal distribution z, and use that to calculate uncertain margin of error, okay? So let's go ahead and do that. This is the formula for the margin of error. So our problem. A poll of 49 voters found that 57% favored Donald Trump. Use the sample data to create a 95% confidence interval estimate of the percentage of voters that favor Trump. All right, so I see a few numbers there. One of them I see that n is equal to 49. N is equal to 49. So basically, in my sampling distribution, all these samples are of size 49. All these samples are of size 49. And we found p hat to be 57%. So p hat is the sample proportion. This is the proportion of those 49 voters who favor Trump. That's 0.57. And that means that q hat, which is 1 minus p hat, is 0.43. I also see here that I have 95% confidence level. Well, the 95% confidence level means this. It means when I'm looking for the critical values, the z values here, right? What I want the critical values that separate the middle 95%, the middle 95%, from the top 2.5% and the bottom 2.5%. So I have 2.5% down here, 2.5% up here in this tail. In this tail up here, I have 2.5. In this tail back here, and I have 2.5. And in the middle, I have 95%. Okay. Now I need to find the z-scores that separate these values. I need to find the z-scores that separate these values. Remembering that the areas down here are going to be the same as the areas up here when I find the margin of error, okay? So that's what this 95% is for. That 95% is the confidence level. We need a 95% confidence interval, so that 95% is the confidence level, 0.95, okay? Um, the complement of the confidence level is called alpha, the significance level. And alpha in this case is 1 minus 0.95, which is 0.05. What I did to find these 2.5% up here at above and below was I just took my level of alpha, 0.05, and I split it up amongst both tails. I found half of alpha. So I took 0.05 and divided it by 2, 0.05 over 2 to get the 0.025, all right? So that's how this 95% gets worked in. So I need now to find the value that separates the top 2.5% on the Z table in the Z distribution. So let's see. Here's the Z distribution table. I have here Z scores going down the first column and across the first row. If I add the number from in the first column to the number in the first row, I'll get the Z score to 2 decimal places. So I'm looking at this, and it looks like this thing gives me these areas in here are the right-tailed areas. And remember, if you remember correctly, I want 2.5% in the upper right tail here, 2.5% in the right tail. So up here, I know I want 0.025. Well, these numbers, the blue areas, are actually in the meat inside of the table here. So I'm looking inside of the table for the closest number to 0.025, and that is right there, 0.025. So if I want the area in here to be 0.025, this number right here, then I need to use the sum of 1.9 and zero point zero 0.06 as the z-score. So that means that this z-score, which is 1.96, separates the top 2.5%, 0.025, from the bottom 0.975, 97.5%. Okay? So that's exactly the number I need, 1.96, 1.96. So going back here, I know that this number up here is 1.96 that separates the top 2.5%, 1.96. And because of symmetry, because this thing is centered at 0, the number back here that separates the bottom 2.5% from the top 97.5 is actually negative 1.96. Negative 1.96. All right, so now coming back to this up here, I need to calculate my margin of error to see how far my p hat is from p in order to be in these particular percentiles, 97.5 percentile and the 2.5 percentile, okay? So let's see. I need to calculate E, the margin of error. So E is equal to, let's see, it's going to be Z, which is 1.96, multiplied by the square root of P hat, which is 0.57, times Q hat, which is 0.43, 0.43, all divided by n, which is 49. And this is equal to approximately, it's actually not equal to, but it's only, let me give you the approximation here. Two decimal approximation would be 0.14, 14%, all right? That's the margin of error, okay? So now let's talk about our sample. Our sample value, 57% was our value of p hat. So let's assume that that 57%, that 57% p hat is an overestimate, 0.57. So in reality, p is less than p hat of 0.57. Well, if it is an overestimate, I want it to be in the 97.5 percentile, meaning I only want 2.5% to be in this upper tail, 0.025. Well, I know that that corresponds to a margin of error of 14%. So basically, if I take my 0.57 and I subtract from it 0.14, the result there being 0.43, 0.43, this will be the margin of error that captures the p. You see, any other margin of error would be too small. If I started at p hat and went back any less than 14%, I would not capture p because I overestimated p and I want it to be in the 97.5 percentile, or I want it to have 0.025 above here. Okay? So that means that 0.43 is my lower confidence interval bound. 0.43. That's as small as I would expect the population proportion to be if I overestimated it with p hat. So if I overestimate it with 0.57, the smallest I would expect it to be, my margin of error is 0.14. So I expect it to be as low as 0.43. Okay? Now, let's say that my 0.57 p hat, let's say my p hat of 0.57 is actually an underestimate, 0.57. Let's say it's actually an underestimate. What I want is I want only 2.5%. I only want 0.025 in the lower tail region here, and I want to use the margin of error that is long enough to capture p hat if I underestimated it with 0.57. So I need to know what I get if I add margin of error e to p hat. Well, that means I'm going to take 0.57 and I'm going to add to it 0.14, and that sum is 0.71, 0.71. So that's, if I'm going to have an upper bound for my p hat, is going to be 0.71. So what I've basically done there is I've taken p hat and I've added and I've subtracted the margin of error e. When I subtracted the margin of error, I got 0.43 as a lower bound. And when I added it, I got 0.71 as an upper bound. So this is my confidence interval estimate for the population proportion, meaning I expect the population proportion to be somewhere between 43 and 71% for Donald Trump supporters.